So today we get to talk about scatter plots. Now, most of you have worked with scatter plots a lot, but I don't know in what depth. So, Okay. But you did do it in 7th grade, right? And then sometimes they introduce it in 5th grade as well. So, some of the stuff you're going to already know. Please. Some of the stuff you're going to know. Some of the stuff you're not going to know. Take notes on what you need. So please keep the phones away, get your papers out, right? So let's take a look at scatter plots here. So we're going to just start off with, what do you already know about scatter plots? So when I say scatter plot, what do you think of or what do you know? Destiny. Right. Usually, right? Very rarely they'll all be in a line. All right. So for scatter plots, right? So is there an image that comes into your mind when you think scatter plot? Or when you hear scatter plot, what image shows up? Is that really an image? Can something be ubiquitous? Okay. Bunch of dots on a graph. Okay. Is it the entire graph or is it part of the graph? Part of the graph. Which part of the graph does your brain tend to think of? Which quadrant? First quadrant. We tend to live in the first quadrant when it comes to scatter plots. Okay? The reason for that is because we tend to compare just two pieces of data. Well, for scatter plots, you can only compare two pieces of data. So these are called bivariate. Okay? So the word bi, again, just means two, right? And variate means variable. So we're going to have two things that are going to be compared together. So we tend to use, like, measurements, right? Like, am I going to compare, like, how many fruits you eat a day versus how many dogs you have? Is there any kind of a connection between that? Right, they're two very different things, so there's no correlation in them, so why am I going to compare those two? But if I were to compare your foot size to your height, they're both connected to you, and there is a positive trend with that, right? People that are taller have bigger feet, which is why, like, Shaq rocks a 23.5 size shoe. His foot's almost 2 feet long. So we know that going in. If I measure something, can I have a negative measurement? Like, can your foot be negative inches long? Okay, can you be a negative height? So you can lose height, but you're still at a positive height, right? You can't exist in the past. Everybody okay with that? Yes, no, maybe? So because of that, we tend to live in the first quadrant where the x and the y-axis are positive. Do we have to be in the first quadrant? Absolutely not. It depends on what you're measuring, right? If you're measuring like average sales of something and you're looking at positives and negatives, if you get a negative value, you can be down here. It's just that we tend to be in the first quadrant because we're tending to use a measurement, which is never going to be a negative. Is everybody okay with that connection, yes or no? So I just don't want you to think that because you are going to see all of your scatter plots in this section in the first quadrant, that scatter plots are always in the first quadrant. They can be anywhere on the graph. It's just that about 90% of the time that we actually use them, they are going to be in the first quadrant. Okay? And then what do they look like? What did you say? Okay, so what do I use, though, to create the image? Like, do I draw up, like, little Mickey Mouses, or what do I use? Okay, I just use points, right? And what does each point represent? Okay, these are x and y coordinates, right? But each of these is considered, it's called a case. But, like, if I were to ask all of you something, right? I don't care what it is, ask you whatever. And I graphed it, each of the dots would represent what? One of you, right? So it's more than just the answer. It's who is that related to? Okay, and that's what I mean by a case. All right, so if I'm comparing average house income by year, right, each dot represents a different year. So everybody okay with that? Yes, no, maybe? All right. So that's how, what we know. What else do you know about scatter plots? Anything else? Anybody know where they're used? How they're used? What they're actually used for in the real world? No? Okay. You said yeah? Oh, okay. Okay. Well, it's bivariate data, so I'll just throw that up here to be a little bit more clear. Anything else? Is there anything else you know about a scatter plot? Anything else we use? Any other tools? Any other terms? Okay. So what we need to know prediction lines. This has another name. It's called the line of best fit. Anytime you use a scatter plot, you're going to do a line of best fit. Okay? Does anybody remember working with this before? A little bit, you remember the term? Okay, we'll go back through it. What about this? Those are R's. They're just not very well made. Anybody in here ever worked with a correlation coefficient before? Okay. It should have been, again, in econ, right? For scatter plots. And then uses. So this is pretty much everything we need to know about scatter plots. So line of best fit. Anybody remember anything about a line of best fit? Wait, what does it mean, though? What is it? Does anybody remember what it is? Okay. Anybody remember any of the rules about it? Okay. So a line of best fit is our prediction line, right? So we actually have a big mathematical process that we can use called linear regression in order to find the precise line of best fit. We're not going to worry about that in this class. This is just more of like a general overview for some reason. But we're not going to get really deep into it, okay? So a line of best fit for you, the more accurate your line of best fit, the better your predictions are, okay? So for us, a line of best fit is a line that gets as close to every single data point we have, all right, at the same time. Okay, so you guys know like how the Earth rotates around the sun, right? But why is it that the Earth doesn't just get sucked into the sun? Right? Because the sun's pulling us toward it, right? But all of the other planets behind us are pulling us the opposite way. So it's as those forces balance out, that's why we get the orbital shape that we get when we rotate around the sun. The line of best fit is kind of the same thing. Every data point is going to be pulling against it. It's going to be tugging it. Okay, so the big data points are going to be trying to force your line up. The data points on the bottom are trying to force the line down. And we want the line to get as close to everything as we possibly can. So what we do is we try to, that's really ridiculously big. We try to put it as close to like the middle of our data set as possible. And what we want is we want it to pass through 2 points. Because if I give you 2 points, can you find the equation to the line? Yeah, it's what we did last chapter, or last section, right? I give you 2 points, you're going to calculate the slope of the line, take the slope in one of the points, plug it into point slope form, you're done. Okay? So for us, if you notice, do I have about the same number of points above the line as I have below the line? Yeah, and what about the distances? Like the distances between the points above and the line are about the same as the distance between the points below and the line, right? That's what the line of best fit is all about. Its technical name, or one of its other names, is called a least squares line. And you can actually calculate the distance between the point and the line. And what you want is if you take all of the positive lines and all of the negative points and add their differences to the line, you want to get a 0, okay? So if you notice, right, the distance from here, from this point to this line is about the same as the distance from this point to this line, correct? Right? And this one to this one is about the same as this one to this one. Everybody okay with that? Yes, no, maybe? Yeah, that's a really generic way of doing it. And by that, I mean it's a really simple way of doing it. You can do it that way, but it blows apart our accuracy. Because if I have, like, my first point is way the heck down here, and my last point is way up here, I'm going to miss a big chunk of my data. So what I want you to do instead is just trust your eyes, okay? You do not have to pass through the origin. In fact, you should not be passing through the origin on these. Some people were taught that you always use the origin. That's a no-no. All right, when I give you your data, I want you to just kind of use your eyes and go, okay, where does it look like the middle of my stuff is at? Okay, so there's going to be some room for fluctuation on this, and that's not what I wanted to do, so if you give me 1 minute here. Come on, computer. There you go. Let me do it this way. Okay, so I can use any line up here, right? But, like, is this line close to all my data? Even though it's passing through 2 points, right? What about if I were up here? Okay, what about if I were like that? That one's not terrible, right? And it's first point, last point. Everybody okay? To me, though, passing through these two would give me a better picture. All right, we're going to be limited in the image we can create because we have to pass through two of our points. Okay, but just kind of trust your eyes on it. And what I do, just so you all know, is I look at the 2 points you use, I look at how you got your equation, and then I double check your equation. All right, so your numbers can be different than mine, and you can still get full points as long as you're following the process accurately. Is everybody okay with that? Yes, no? So don't worry if you look it up in the back of the book and you get a different number, but you should be close, okay? If the answer in the back of the book is like 186 for the prediction, and you get like 43, there's an issue. Everybody all right with that idea? Yes, no, maybe? Okay. So everybody remembering your stuff, you think, maybe with scatter plots as far as the line of best fit? Okay. And seems like what we did last section, is everybody okay with how to find the line of best fit given 2 points? Kind of. So this is where it's the two-parter, right? I'm going to give you 2 points. You're going to find M using slope formula, and then you're going to find the equation using that formula. So for line of best fit, you're going to be using these two formulas, right? You're going to find 2 points, use those to find the slope, and then use the slope in one of those points to find the equation of the line. Is everybody okay with that, right? And then the last part is it's going to be kind of like the last section, right, where you had to find the equation and then use the equation to make a prediction. Same thing here, okay? They're going to ask you to find the equation of the line of best fit and then find y when x equals something. Is everybody okay with that? Yeah? All right. So going on to correlation coefficient and stuff, making a scatter plot. So first thing that I need is, we'll just do 8 points, okay? So give me 8 numbers between 0 and 10. Lame. I don't want them in order. Come on. So? Things can show up more than once in reality. I mean, I'm not the only person in the world that's 5'10" and a half, right? 7, 8. All right, so I need 8 more. Between 0 and 10, dude. I don't have enough room for that. Okay. So now I'm going to plot these points, right? Now, for us, it's not going to really come into impact too much. But what's my smallest number on the x column? 2.6. And what about on the y column? It's going to be 1, right? So is it easy to count to those? Yeah, but when we were doing shoe size to height, right? What's the smallest height in here? Like what? Like 5 foot something, right? Okay. So if our smallest value is like 61, right? But our biggest value is only going to be like 75, right? If I set up my scale so I can count out to 61, say I'm counting by tens, right? All of my data is going to be compressed into a really small area. Okay, if your data is compressed, is it going to be easy to see all the patterns? No, you want it spread out so it looks nice, right? So you can see exactly what's going on. So what I can do is I can use something called a break. Anybody in here know what a break is? Huh? Kind of. You're only allowed to use one break per axis, and it has to be before you place any dots on the graph. So you can't, like, place 2 dots and then put in a break. Okay, what a break does is it allows us to start counting wherever we want. So if I were doing height, I don't want to count out a huge distance of nothing, right? If our minimum is 61, and let's say height is the x, what I'm going to do is I'm going to put in a break. A break looks like an EKG, and all it does is it allows you to start counting wherever you want. So now my data will be spread out and look good, but I don't have a huge waste of paper where I'm not doing anything. Is everybody okay with that idea? Yes, no, maybe? All right, so feel free to use these, but you got to remember the rules. No data points should be to the left of a break or below a break, because you can use one per axis. So I can use one on my vertical axis if I wanted to, and it'll look like that. And basically, all you're telling the reader with a break is just like you're grabbing the x-axis and you're pulling it down. Okay, so it's like zooming in. Is everybody okay with that idea? Yes or no? Yes, sir. You can have one on the x-axis, one on the y-axis, but your data has to be past the break. So like if we had an oddity in here, somebody was like 3'2", right? That has to be to the right of my break. All right, so I could still use a break, but I'd have to start counting my graph at like 38 inches. You see what I'm saying? So you can't like have like the outlier and then put in a break. So you can't like break, dot, and then another break. You're only allowed one, and all of your data has to be past the break. Okay? Yes? Okay. So it's one of those things where we only use it if the smallest number we have is a big distance away from our origin. So we use it just to kind of zoom down so that way we don't waste a whole bunch of paper trying to create these giant scatter plots when you can just zoom in and get a good picture. Correct. So like this one, would I use a break? No, because my smallest, everything's between 0 and 10, right? I mean, I told you that, but because I don't have stuff spread way out, I don't need a break. Everybody good with that? Yeah? Yeah. So what quadrant are we going to be in here for all of my data? Positive on both axes, so it's the first quadrant. So I have positive y's, positive x's. Okay, what do I need to count by on my y's? Or how many pieces do I need? What's my range? Okay, between 1 and 10, so I'm going to go 0 to 10, right? Okay. And just like always, we have to mark the scale. Okay, scales are going to be huge in this section. Because remember, your x-axis and your y-axis can use different scales. All right, so it's going to be one of those things where every problem you do, you're going to be trying to figure out how do I make it look right. Okay, so based off of how your data is set up, you're going to have to more than likely change your scales because remember, you guys are doing these on graph paper, right? So you're going to try to get them to fit on the graph. Everybody good with that? Yes, no? So make sure that you're counting and telling me what your scale is. Yes, sir. A couple of different things. You're trying to find the line of best fit so you can make a prediction for an unknown setting. And you're trying to find the correlation coefficient and identify whether the correlation is positive, negative, or none. So that's what we're going to be using our scatter plots for. Okay? So what's my first point? 5, 1, right? So I go to 5, I go up to 1, put a point. Everybody okay? Yes or no? All right, what's my second coordinate pair? 4, 3. 3, 4, 5, 6. 3.5, 2. 2, 5. 2, 3, 4, 5. And 9, 10, right? 7, 8, 9. Everybody okay? Yes or no? All right. So if I ask you to identify the correlation up here, right? X and Y are connected to each other. Whatever I'm measuring, they've got to be connected, right? So we have 3 types of correlation. We have positive correlation, negative correlation, and then relatively no correlation. And it's basically all connected to the slope of the line. So if you were to graph your line of best fit with this equation, right, what way does it look like the line is going to be pointing? Does this data look like it would form a line? Could you make a prediction line out of this? Yeah, I could make a prediction line, right? But which way does the slope look like it's going to be going? Does it look like the line's going to be pointing up, pointing down, or just we don't know? Huh? Well, as we move from left to right across the X, what's going on with our Y's? Are they getting bigger or smaller? Bigger. So that means that my line would be rising, right? So is this line going to be pointing up or down? So is its slope positive or negative? Positive. So what we do is we identify this as a positive correlation. Okay, so whether a scatter plot has a positive correlation or negative correlation is actually based off of whether the prediction line has a positive slope or a negative slope. Okay, but are there any major questions on how to make a scatter plot? Okay, and for line of best fit, we'll come back to this. But for right now, take a look at this set of data on top. All right, if I asked you to identify its correlation, what are you thinking? Positive, negative, or none? Okay, why positive? Okay, so if I were to draw the line of best fit, it would be something like that, right? Okay, and the slope of that line is? What's the slope of the line that I drew? Positive, so this is a positive correlation. Everybody okay with that connection? This one? Is the line rising or falling? Falling, so is its slope positive or negative? So it's a negative correlation. Everybody good? All right, and then the last type. Is it rising, falling, or neither? Neither, it's just all over the place, right? So this is considered a no correlation. As in, like, any prediction you make is going to be useless because there's no real connection between X and Y. So remember that first example I gave on where it's like the number of fruits you eat to the number of dogs you own? That would present something like this because there's no connection between the two things I'm looking for. The two variables are not connected at all. Okay, everybody good with that? Yeah? All right, so this is where, like, on your quizzes and tests, you're going to get quite a few questions like this about identify the correlation. All right, so everybody good? All right, line of best fit. Again, if I gave you or asked you to find a line of best fit, how many points does it have to pass through? 2, and the reason for that is so that way we can actually find the slope and then find the equation of the line. Everybody good? So, again, real quick, is this a positive correlation, negative correlation, or no correlation? Positive. And where about would you say the line of best fit should go? So let me, okay, so where? Up. Do I need to bring the ruler like that? Okay, say one. Like that? So, if you look, if that's close, right, how many of the data points do I have to pass through? 2. So what I'm going to do is I'm going to look and say, okay, are there 2 points that I'm really close to? Yeah, I'm already going through this one, right? I'm really close to this one, and this one. Okay, so what I'm going to do is I'm going to slide up a little bit so I'm on this point. And then I'm going to kick down. Actually, I don't get the option to because my calculator's got to snap the grids. So there we go. So if you notice now, how many points am I passing through? 3, which is never a bad thing, right? Does it look like that line gets really close to cutting through all of my, or cutting right through the middle of all my data points? Okay, so no, what Vicky's saying is that this point is way off the line, right? Do I really have a negative counterpart to it? No, and I've got this grouping right here that doesn't have a group underneath to match. So what she's saying is that I need to move this end up, right? Okay, so what point should I use instead? Which one? This one? Say one. From here, where do I go? Like, which point? No. I want to know which point I should pass through. Because I have to pass through 2 points. Okay, so if this point should be okay, right? So which point should I go to? This one? Okay. Yes, Raina. Okay. So I'm going to regraph my line, except I just erased my data. So I'm going to use this one and this one, right? Everybody okay with that? All right. All right, so does that look better? All right. So, any questions on how to find the line of best fit? So sometimes you look at it and it looks fine when you got your ruler up, and then you look at it after you graph and you're like, maybe I should move this, maybe I should move that, right? The important thing here is you got to remember you're passing through two of your points, so you can only move to where you have another point. Everybody good, yeah?
Yeah.
All right. And is everybody okay with how to find the equation of a line given 2 points, or do you want me to run back through that? Yeah. So let's say we find our line of best fit, right, and it passes through these 2 points. So it'll pass through 2, 6, and 8, I don't know, 11. Okay? Everybody all right with that, yeah? So this one, is the slope going to be a positive or a negative? Positive because the second point is bigger, right? X is bigger, Y is bigger. All right, so if I ask you to find the equation that passes through those 2 points, walk me through it. Okay, so M equals 11 minus 6 over 8 minus 2. What's 11 minus 6? 8 minus 2. Oops, shoot. Yep. Can that reduce at all? Okay, so I have my M. So now what do I use? Which form? Perfect. Okay, now does it matter which point I use? Does it matter which point I use for my X1, Y1? Okay, so which one do you want to use? 2, 6? Okay. So what do I write? Y minus 6, because that's the Y, right? 5, 6. Everybody good?
Yeah.
All right. Y minus 6 equals 5x over 6. Everybody okay with getting to that point, yes or no? So now how do I get y by itself? Add 6, so I get a common denominator, right? So 6 becomes 18 over 3. Everybody okay with that? And what's negative 5 plus 18? 13, so I get plus 13 over 3. Can that get any smaller? No. So that's the equation to my line of best fit. Yes. So it's just like what we did 2 sections ago. Everybody all right with that idea, yes or no? So that's why this stuff is in this section, okay? In order to find the line of best fit, it's where we actually use this information, okay? And real quick, before we go on, scatter plots. Do you think they're used a lot in the real world? Yeah. And the reason I say that is, how many times do you hear on TV somebody making a prediction? Right? And you've also got, the main thing is like government, right? You hear people talk about when the government's going to run out of money at this point, right? The government needs to invest in this. This is what's happening. This is what's going on. All right, this is how many average house income in America. This is the average student debt. This is the average this, the average that. All of that information is coming out of scatter plots. Okay? Cost of college has gone up this percentage. Well, how do they know? It's because they're tracking it over 50 years. Okay? And why we want to keep gathering data on that stuff, like the U.S. Census every 10 years, is because it allows us to adjust whether our prediction is right or wrong. Okay? If we expected this to happen and we have the opposite, then we need to add that data in and make an adjustment to our prediction line. Is everybody okay? So if we stopped gathering that information, our predictions would be pretty much useless because they have no bearing on reality anymore. All right, so what we do is we gather information from the past, use it to make a prediction for the near future, and then when the future is past, we check to see if our prediction was right and then make adjustments to it. Everybody okay with that? So anytime you hear the government say that they're predicting something's going to happen, it's usually connected to a scatter plot. Okay? So it's used a lot. It's just, like Destiny said, you don't know it. Because we don't show you all of this stuff. We just tell you what the prediction is, right? You don't hear a lot of people in government talk about, well, if you look at the scatter plot, it has a correlation coefficient of... That doesn't happen. It's We think this is what's going to happen, so this is how we should prevent it. Everybody okay with that? Yeah? But this is why, like, the government hires statisticians. There's people who get paid government salaries for doing just this. They gather information and they gather data, and it's not just the government, okay? GE, General Motors, Ford, anybody who produces something. This is also how we predict trends. Last thing, correlation coefficients. A correlation coefficient relates how accurate our prediction is to the data plot, or to the data we have. So correlation coefficients are always between -1 and 1. Okay, if the correlation coefficient is negative, that means that your line's pointing down. If the correlation coefficient is positive, that means your line's pointing up. Everybody all right with that? All right, so it tells you how accurate your prediction is. So the closer to 1 you are, the more accurate your prediction will be. Okay, so if you have a correlation coefficient of 1, that means that your data, like on your scatter plot, your data is right next to the line. Okay, your prediction is almost perfect for the data you have. So that means that your predictions that you make should be really good, right? If R is 0, then that means that you have your line of best fit and the data is all over the place, right? There's like no connection at all between them. Okay, so let me show you what I'm talking about. And don't worry, I'll come back to this page. This is actually the formula for correlation coefficients, which you guys don't have to do. But understand that when I teach you how to do it with a calculator, it's doing a lot of work very quickly. So here's an R, which is the letter that we use, not R squared, but R is the letter we use for correlation coefficients, right? What's your R value here? 1, right? What do you notice? The data is what? Is it close to the prediction line? It's perfect. So that means that if this is your prediction, you should be predicting exactly what's going to happen. Okay? This is like what the psychics online pretend to be. Everybody okay? All right, so here you notice that the R is a little bit less than 1, and what you notice about the data. Is it all on the line? No, but it's really what? It's really close to the line. Here, your R is a little bit worse, and the data is what? Further off the line. Is everybody okay with what I mean by connection, or by a correlation coefficient being something that tells you how accurate your predictions are? Okay, so the more accurate your prediction, the closer the data will be to your actual prediction line. Okay, and then here, things are worse, things are pretty bad, things are really bad. So if I had this situation down here where my R is super small like that, close to 0, does my prediction really mean anything? No, yeah, this is a no correlation situation. So this means that my prediction is pretty much garbage. I could be saying whatever I want to. All right, and the data will back it up just as likely as if I'm right. Is everybody okay with that idea, yes or no? Okay, so coming back, so again, if R equals 1, then that means that you have a perfect positive correlation, which means that your every data point is really, really, really close to your line of prediction, but your line is going to point up, okay? You're going to have a positive slope. Everybody okay with that idea, yes or no? Okay, one person saying, yeah, I hope everybody else is on the same boat. If R equals a -1, then that means that you have a perfect negative correlation. So that means that all of your data is still pretty much on the line, but instead of your line pointing up, it's pointing down. Everybody okay with that? Yes? No? All right. And then if you have an R of 0, then that means that you have no correlation, which means that you have your dots all over the place, and the line really isn't going to tell you anything, so you can't make a prediction. Okay? Everybody all right with that? Connection? Yes? No? Maybe? All right. So it's important in here that we get the terminology down. So if I talk about a correlation coefficient, you'll know what I'm talking about. Okay? And the correlation coefficient is more than just this fluff thing. It's really important. Because if you're going to your boss and saying, hey, we need to do this because look at the prediction, this is what's going to happen, whether they listen to you or not is based off your correlation coefficient. Okay? If you make a fantastic prediction, like your company is going to become this huge thing, but your correlation coefficient is weak, that means that your prediction is weak. Okay, if your correlation coefficient is strong, that means that your prediction is strong and more likely to happen. Everybody good with that idea? All right. I just want to make sure that you're good on correlation coefficients. All right, and that's it. So here's your homework.